I think that a lot of people currently now in software engineering have no clue that what they do as software engineers has impact on the energy usage of their systems. And I hope to kind of elaborate on that today.
Hey there, welcome to Better Talks, the podcast.
I'm Rick.
And I am Oscar. And today we are joined by Wilco Burggraaf, Principal Lead Software Architect and Green Software Advocate working at the intersection of Azure, C#, open source and sustainable engineering. Welcome, Wilco.
Welcome.
Hi. Yeah, it's amazing to be here. And especially because I think that a lot of people currently now in software engineering have no clue that what they do as software engineers has impact on the energy usage of their systems. And I hope to kind of elaborate on that today.
Well, please dive right in, because that's one of the things that really stands out, right? Sustainable engineering.
Yes.
This is a man with a mission.
But I think a couple of years ago, it was a topic, right? Companies were publishing reports on their amounts of CO2 that they were either using up or
it was good marketing.
Yeah, and I think there was some.
Don't say that out loud.
There was some greenwashing there too, now and again.
Yeah.
But especially nowadays, with all of the compute going into, for instance, AI, I can also imagine that those footprints are maybe not so interesting anymore to show. Where does your interest in your, like Oscar said, mission come from, that you actually want to make sure people know about the impact that what they do has?
Yeah, so maybe a little bit of a backstory there. So 2 years ago, I participated in a hackathon. I mean, we love to code, so good start of the Green Software Foundation. And we won the best contribution. And the main thing that we did was there was a framework, impact framework. It's still there. And it's a tool that helps you measure the amount of emissions, but also other negative impact. And we kind of created a way that this console application was also usable as an API, but also could kind of predict. It was a use case of, you could kind of say picnic. I don't know, allowed to say brands here, but of picnic, where you have an electrical vehicle delivering a certain package to someone home. And from the buying of the vehicle, the, how do you say it? The energy...
consumption?
It needs to load, right? It needs to charge.
Yeah,
Thank you.
charge,
Energy charging. There we are. So the energy charge of the vehicle at what moments that was the best case to do. But also the materials, like I said, used for the producing, and also you have a certain road from A to B. So how do you have your optimal roads, and how do you do that in a way with the minimal amount of emissions? And we built all this in this impact framework, and they were kind of very, how do you say it, enthusiastic, because to that point it was only like, okay, how can we use this methodology purely for the hardware of the systems itself, but you kind of can do it for everything. And that's why we won. But from that moment, I was really like, okay, as a developer, as an architect, or as a platform engineer, I kind of don't have a clue where to start to make my work more green or more sustainable. So that's why I started to talk with, in the first year, with more than 100 people in my free time, 4 to 5 conversations each week, especially in the beginning with professors and assistant professors, on how this kind of works. And in the core, in the beginning, there was a professor who told, like, hey, you have the compute efficiency, but it is not the same as the energy consumption of systems. There's not always a direct correlationship. And that's also why it was very interesting to me, like, okay, so it is more complex than a lot of people think, because most people think if you make software very of a good quality and very fast, then it's also probably going to be green and sustainable. And from that perspective, I went on in finding out, okay, what are better ways of measuring, creating eventually trainings on how people can actually then start doing this stuff. I can talk about more in details that later. And that eventually, I think, converted more from just looking at emissions into finding digital waste. And finding digital waste, you can sit with a development team, and within 10 minutes, they can explain to you all the things that are not allowed to work on, that are going inefficiently around in the system, in how it is developed, and all that kind of stuff. So yeah, that is kind of the core of that all. Yeah, now it's since January my full-time job. So I help like organizations like Rabobank, Team System, also with a complete team of 5 people now, with setting up the strategy, and also setting up policies to eventually make this work in the sustainable IT department or the IT operation of what you do every day.
I just wanted to ask, and you already mentioned now that you made this a full-time job, so that's kudos actually. But I can also imagine if you look in a grander scheme of things, you might feel like you're in Dutch you say een roepende in de woestijn, which means somebody's calling out in the desert and there's nobody's listening.
Drop in the ocean.
Do you feel like that sometimes, or is there more?
That's a good question,
and
because
energy now for that.
What I left out in the what I just mentioned is that since April of 2024, together with Pini Resnick at the time, we started meetups, just like what you see happening around .NET meetups or CNCF meetups and that kind of stuff. And we grew within 4 months, I think, to 500 or 600 people. Just in the Netherlands. Yes, now we have like 1,000, almost 1,000 members just on this topic. So that also gives you a feeling like, okay, I'm not the only one. In the Netherlands alone, we have more than 10,000 people who mention on their LinkedIn that they care about sustainability and green. So, and when you look at sustainability officers, which is kind of most of the time the role within an organization who look at this, we have more than 1,000 in the Netherlands, sustainability officers at large organizations. Marketing is not talking about it anymore because of certain reasons in the world. That's a different story. And also to give you an idea, I'm also a big fan of Green.io. That is also one of the first podcasts that I listened to of Gael Dues. Funny story is that I'm literally now organizing Green.io Amsterdam in a month now, together also with Gael. But Green.io is as an example. They expect Munich to have more than 1,200 per people who attend. And Paris this year probably more than 3,000. So just on how you say, responsible IT usage in general.
Okay.
So yeah.
So you're not the odd one out that's calling out for this. It's actually a big thing.
Percentual, you could say we're in our own bubble. Sometimes you believe your bubble is big, but if you compare it to the whole IT space, maybe it's small. But let's take, for example, Microsoft. So Microsoft, the whole Green Software Foundation, which is founded by Microsoft and GitHub and Accenture, Avanade, and a lot of other organizations, that was eventually, funded by the group within Microsoft, the grassroots movement, who grew to 10,000 people within that company who were busy with this topic. So, like I said, often there is not talked about, or you have to be in a certain bubble to get that information. But yeah, there are a lot of people looking into this.
Yeah, I see, like we also mentioned it in the start, like a few years ago, everyone was showing off and there was a lot of attention and marketing on. And Cloud Compute was saying, like, reporting CO2 and like their missions and yeah, because mostly I think global politics and some opinions there. It's not powerful anymore, or doesn't contribute to the bottom line of those big companies, because in the end, like mostly they're driven by revenue. So if this is hip, they will promote it. If it isn't, they won't. Did that, and I think on top of that, more waste than ever with AI now. Because I just almost feel dirty sometimes using AI assisted coding. It's like
you shouldn't.
generating.
You shouldn't. I explain that. I can explain.
Okay, but that's good. But like does it feel like you've been like pushed back 10 years, or
no, not at all?
It's like more call to mission than ever.
So the funny thing is, to give you an idea, if you set up a sustainable IT department within an organization, your 3 core pillars are FinOps, which is very, I think, a big thing right now, observability, and procurement information. And the core thing is, if you want to, so maybe also a core concept is for each kilowatt hour, also in the Netherlands, location-based, you indirectly emit emissions, mainly because even if you have renewables, you need gas turbines, mainly in Limburg in the south, in the Netherlands, to stabilize the grid. So whatever you can say, you have a green contract, great, but from a science perspective, you will always have emissions based on the energy you use. And then if you look from that perspective, okay, we want eventually to optimize our software from an energy perspective. You most of the time will also, improve the quality of your software. Because also the people who are really into this, they want to know everything about the resources, cloud resources, real resources they use, so they want to improve it. And if you start doing that, what you will see happening is that you most of the time, for at least 50 to 60%, will reduce the amount of cost. And also, you probably have a lot of things you have as overhead that you do that you can reduce in, so you can perform better financially as a department, as well as just as an organization. So it's behavioral, it's the deliverables you literally deliver. So that's why. From the moment organization starts to understand, oh, wait a minute, so this is about the quality of our computing workload of the whole organization, and we can actually benefit from this. And then that data gives you the best data for reporting once the ESG team is like, because now most of the time IT is not included in the reporting. They just, scope 2 is like, we have a green contract, so we put a default number in there. Scope 3, if you have hyperscalers under purchase goods, is like, this is maybe a story on its own, but so now that you have that data, you can give it to the report team. They are very happy with that. So you create kind of a chain. And once an organization will start to understand, wait a minute, so we benefit, we have better data, we're more compliant. They start to understand we have a return of investment in this, something that AI also lacks on. Funny story is that because of our knowledge on resources and how the processes work and how you can do things more efficiently, we can actually use AI to create AI projects that have a clear return of investments, which a lot of CTOs like. So the core concept is, I think it's only growing, and it's. I think most people in our in our community have talking too much and too long only about emissions, only about CO2. That's also why I talk more about digital waste. And once I think this starts to grow further, which, like I said, in the grassroots, in the meetups, in the conferences, the group of people want to do this, it is growing. I think this is still a hype potentially to still happen. But yeah, that's from my perspective. I mean, I'm very passionate and enthusiastic about this, but
yeah, but you can also hear in everything you say and the way you talk about this that you're really quite far into this knowledge, but. Because I also can imagine that people listening, maybe this goes a bit too fast for them. So to take 1 or 2 steps back, how do you go from caring about sustainability and caring about green coding into actually practical engineering mindset or discipline, right?
Yes. So the core thing is, if you look how the software that we write interact with hardware, and mainly this has to do with the CPU and memory. And although some people in the community say that I talk often too much about CPUs, but because you normally have to look at the energy of the whole system. But there are 3 generic principles that I found at the end of 2024. One is underutilization. So often what you will see, especially in financial institutions, that most virtual machines and servers only run on 20 or 30% of the CPU utilization over the whole year. So the unwritten rule in sustainability is as well, if you have resources that you have access to, try to use them as optimal as possible with the least amount of negative impact. So, and that has a lot to do, I often say, green coding and async and parallel coding, which a lot of people find still very hard, especially in Rust, although it's a very efficient language. But underutilization, that's one of them. The second one is waiting. I don't have to probably explain that I've seen so many times that I see a while loop going on that is just waiting and using a full core with actually kind of doing nothing. But you also have waiting on architecture level, serverless, we can talk about that kind of stuff. The third one that I always talk about, it has a relationship with waiting, is bottlenecks. So how often it happens that someone upgrades CPU cores, also virtual and containers, virtual machines and other solutions, CPU cores, memory, before they found out that the database was actually the issue or another thing you called was actually the issue. So bottlenecks have a strong relationship with energy consumption of systems. So these are all things that we have influence on. and often way more than we think. So if you look at the operating system utilization and energy is often never beyond 10%. Maybe a Kubernetes system, an extra virtual layer can also be at 10%, but okay. But that means that we have 80, 90%, and probably if you have the perfect utilization of all cores on CPUs is 70, 80. So let's say that you have 60% of an influence. That is a lot. And by how we design systems, by how we write the code, we have influence on this.
I think it's like no matter which angle you approach it from, like this seems like just a way in to get the whole thing performing better, like working better, and it's not like performance, but like being efficient, not doing things you don't need, and in the end, like bottom line, this will be beneficial for everything, everyone, everything will be. Well, I think in the end, overline will be faster, will be simpler, I guess.
Yes. Yagni, Kiss.
All those, right? I think as engineers, you're always doing this already. But like from this angle.
Yeah, not with the sustainability in mind, right?
No.
I mean, to be honest, for me, that hasn't been one of the inputs that I took into.
No, but like the discussion was always like, yeah, we should actually make this a bit more event driven because now it's a batch job that runs every 2 hours and most of it, like it's hitting every database while mostly 5% is actually changed. Like we should do this, but it's not worth it, not worth our time because we cannot calculate that it's worth our time or not. It just feels dirty that we do it. So we should refactor this and then the product will say like nothing changed. In the end, something changed. Like if you do that, you probably got some new issues.
Functionally,
you didn't have.
Functionally, nothing changed.
No, but like this is such an angle. Like if you have some room from this angle to investigate this, there's a lot of work I would love to do, which I could put this label on.
Tech debt reduction, but to add something else, and because green and sustainability are often used as the same, but they're not the same. So green, and this is my definition, there is no official definition. Green is more from the perspective of renewable energy focused and short term. You can do it now. So to give you an example about code, you can create the most fastest sort algorithm because you think this is way better than how .NET does it or any other cool library. But then from a sustainability angle, the question is, who is going to maintain your code for the next 5 to 10 years? So sustainability is about maintaining something long term. So clean architecture and that kind of stuff. That's a joke, but it has some relationship there. So there is even some more details to that. And indeed, so the most focus from large organizations like Schneider Electric is very known for this, is reducing of tech debt. So what you see is that there is also a strong relationship with because of tech debt not being able to having the most efficient system environment, need extra people to maintain it, having future costs. So tech debt reduction and sustainability have a strong relationship. The other maybe also cool thing to even make this like, oh, wait a minute, this is bigger than maybe I have thought, is that you have the reporting about CSRD reporting. So large organizations with a certain amount of employees, maybe they are noted at the stock. They have to report on their impact. There are a few pillars that they report on. Climate mitigation is still now the thing we talked about. So they're reducing the amount of emissions. The second one is, no matter if you care about climate or you believe it or not, there are more extreme weather events happening. So when that happens, if you have a very warm day or a very cold day, it could happen that the electricity grid gets that it fails. And maybe even the hyperscalers, they have issues or whatever happens. If because of that, people start doing other stuff or your infrastructure start becoming like vulnerable, there is a chance that you get hacked at such a moment, because there are organizations who are literally looking forward to such events and then take advantage of it. It's not a conspiracy theory. Then if that happens, maybe that gets known, you get a reputational hit, and then maybe you eventually end up with less users or customers. that could lead to eventually firing people, and that has a social impact. And social impact is also part of these reporting. And the fun fact is that in every big organizations that I found, cybersecurity, resilience, because of that, also part of their sustainability reporting. So it's not only energy. And then in short, that's why, and Asim Hussein, who was until short was the director of the Green Software Foundation, when I talked to him multiple times, he was like, it's so cool that everything that we ever learned about IT, you in some way you're gonna rethink it. And that's also for me the challenge, and that's also why I'm so passionate about it.
Yeah, but the interesting part, like all the way in the beginning, you also mentioned the with the picnic examples, like actually looking end to end instead of like zooming into that one thing and doing like total impact analysis. This feels sometimes a bit counterintuitive because you mean a lot of you mention a lot of things, and like security, running a scanner in the background, doing all kinds of asserts and checks before you run your code, and like everything we do to prevent a problem might seem as overhead and the direct while loop you're trying to do or whatever. But in the end-to-end scheme, it will prevent, exceptions and things that will cause larger stack traces and have much more impact on the whole thing.
Yeah.
And it feels a bit different because for me, like it feels like, okay, but like if we're checking this all or we're indeed like a security tooling, like it's an extra layer. But if you actually have an impact there, or something happens there, the impact of that is so big in the total picture. It's different. It has a huge impact.
Yeah.
For me, like being naively looking at green coding or whatever a couple of years ago, and I was like completely like, okay, but that's just writing good, efficient code, and of course makes sense. But you need to zoom out way more to actually have an impact there.
Yeah. And I think the also what you said about impact is that is the whole the core ID. So what I always say, whatever you do, you will always have negative and positive impact. And one of the core things an organization will do, and sadly this will never, how to say, trickle down to like bottom up, so from the teams or other things, is a double materiality assessment. So the core idea is that you assess how you have impact on the world and how the world has impact on you. And this is not only from a climate perspective interesting, but just as a business in general. And sometimes we do something for 10 years because it's business as usual. Although we we say to ourselves, yeah, we're innovating. We have a lot of default behavior in the things we do. And because of that, and not really being kind of impacted where in any form, you getting inefficiencies up to like 60% in organizations because, yeah, it works, it's fine. We're emptying the budgets at the end of the year. But CFOs in general, CFOs are now getting to the point that they're saying like, you have to innovate, you have to use AI, but you have a limited budget, and maybe that budget, because of certain situations, have to go down. And I know a lot of organizations where this is happening. And the only way you can make good decisions, because you can try to optimize everything. There is an investment bank in the UK who tried with software to optimize their whole IT portfolio. And after millions poured into this, they started then eventually testing all these refactorings on large scale, and they came to the point that they got more issues and 10 to 20% less performance. So they revert everything back. So the core thing is more, if you want to know where an organization should you focus on, it's often the applications and resources that cost the most. Those are also the applications often that have the biggest impact, and be really aware. So where does this make sense? That's why also with green coding and all that kind of stuff, if you start like improving code for an application that just 5 people use, the question is it a good use of your time? And actually, does it make sense?
Yeah, it's just making the business case like economical wise as well. Like, what I like from this is like everything you would normally skip is like, because it works. Like we always work like this. The classic one, like to actually understand what you're doing and why you're doing that. Like it's a good exercise all the time for everyone, no matter what your reason is.
I just wanted to say that, but that's not even only in IT. That's true
everywhere.
For everybody, everywhere. Yeah,
totally.
So hold that thought. But in the meantime, Do you know what time it is?
Is it already time for a totally random question?
It's time for a totally random question. Oh, wow, this is a good one. If your career so far were a Netflix series, what would the title and tagline be? Now, I say Netflix, but it can just as well be Prime Video or HBO Max or any of the other streaming services. What would your series title and tagline be?
Oh, this is a difficult one.
It is, but I'm trying to think of one myself, but not
sometimes it feels like the series 24 with Jack Bauer, where you have literally every time, because I'm doing two things. So if you really want to make impact, you have to try to focus every time on the right things, and you have a lot of kind of important deadlines every time to move forward. So I also, in the work that I do for customers, don't work to full time for a customer, do like maximum 16 hours, and in that 16 hours to be as efficiently as possible. So when every like 5 or 15 minutes matter, you have like all these big events and for yourself that sometimes they're feeling, and that you have to solve these puzzles before they blow up. But
yeah, I can imagine it feels like that sometimes. That's a nice one, actually. So
did you think of it for yourself? Like I saw your eyes just glazing over while you're asking the question.
Maybe I'll get back to that at the end of the episode. Not just yet.
Okay.
Maybe. So one of the things that I read from your bio is also the fact that, of course, you're also well into .NET development, into Azure, and also cloud efficiency is something that's quite interesting. What my first question would be is there a choice in service you can make that influences the amount of sustainability you have? And I'm talking Azure services here. So for instance, looking at compute, which has a ton of different types of implementations inside of the Azure environment, are there choices to be made that have a positive or negative impact on the amount of sustainability that goes into that system?
Yeah, I'm going to take that more to a practical perspective. So
sure, please do.
Within Azure, the almost always in the top 3 within large organizations, you have data platforms as being the ones who emit the most, cost the most, use a lot of energy. And Apache Spark and Databricks are very familiar in that. And sadly, this is not a .NET example. I wish there was often more support for C#. There is some support within Apache Spark and Databricks, but most of the things are in Python. And what you see, and you see this as well in .NET as well, is that people often are focusing on the end goal within these data, whatever algorithm or machine learning models they create, but the most inefficiencies are often in there. In this space, it's often because data engineers or data scientists are more focused on the data part and on the engineering part. The other thing is that Databricks and Apache Spark, the how do you say it, the engine under the hood, they kind of completely they take the code you wrote and they generate kind of new code on top of it, running it on multiple nodes, and do that in a certain way. And if you write your code in normal Python way, you're taking completely not advantage of that whole system. So, but then bringing it back to .NET even, a lot of people think that they write code very efficiently. And we have a theoretical model that we use in AI where you can analyze, and we always use also observability as well, but you can analyze C# code. And there are so many things that you could write even in a serverless environment that is not like using the resources optimal. Like I said before, building something single threaded because multi-threaded what makes it harder to understand. Or you can go event driven. That can help in some cases. I think event driven is a beautiful system. The question is, how do you wait on when an event is triggered? That kind of stuff. But maybe also from architecture. So if you look at Azure, you can use Azure in multiple ways. So I always say that with cloud, you could to some degree say, I trust my hyperscaler that they utilize the resources as best as possible. So then serverless is maybe a good way to go, not always. If you have your own on-prem system, then you, of course, are responsible for the utilization yourself. So microservices often make more sense. But you also have the other two architectural environments, and that's travel and it's at home. So travel is often, how do you write software that kind of has the best effect on a battery? So I always use this example of, let's say you have a mobile phone. Everyone had an app that overheated their mobile phone. It has actually hardware wear and tear impact on your battery, but you're often not aware of it. So making sure that if you write code, you're not overheating because it's a passive cooled device. That's something in combination with maybe you set something up in Azure. The last thing is at home. A lot of people have solar panels at home, although it's a paper exercise because most renewable energy is is given back to the grid and not actually used. But for the thing, so if you want to be as close to renewables at home, you do more edge computing. So I would say if you build something in Azure, also think about the effect that you don't always have to build everything at the hyperscaler, but you can also do more potentially on the edge because of multiple reasons. So this is very broad, I understand, but there are a lot of things, way more than this that you can do within your. So for instance, if you now use the well-designed framework, is it Aspire? Do I say it correctly?
Aspire, yeah.
Thank you. So you have now kind of the same with what CNCF as well, that you can design something that runs in containers in Azure, but also at the edge in WebAssembly. And those gives you then, once that architecture is up, you can then decide maybe potentially on certain, there is a map, electricitymaps.com, that shows you at certain moments of the day when there is less indirect emissions going on. So you could choose, like, do I run it maybe at Microsoft, or do I run maybe more at the edge where potentially energy is wasted because people don't use it? There are multiple choices you could make.
But that's a hard, pretty advanced thing to do. Even the logic to do that takes energy. So my engineering brain goes like, is it worth it? Is it and for some things it is, and we will get like models on the edges of our phones and in browsers, and what I think they shipped in Chrome, some kind of 4 gig model this week. But to actually do that, depending on the time or even an input, feels like, but then you're building that next to it. It's really hard to prove your case, I guess, or to even measure the total impact. But the idea that we have those options,
even from cost perspective, right? So I expect if you could do sometimes more in scale. Everything is about scale. If you have a few users, it doesn't make sense. If you have million users, it does. So do you always have to compute everything? Most of the time is related to data. So if you have to move a lot of data to do the compute, which in a lot of cases is the case, then maybe moving all the data to the edge and then compute there doesn't make a lot of sense. But there are scenarios where you have algorithms that don't need that much data to do a lot of computing, and then it makes more sense.
Yeah, is there some kind of thing you can get as a rule of thumb or something? Because to me, you mentioned Databricks, for instance, like any data platform. Yeah, and that's moving also the use cases there, and sometimes they're doing, or they're gonna build something, and they know they're gonna build something in the future where they want to have previous data, because it's a bit different than normal software. It's not, you want to be able to in hindsight be able to do something in reporting. Yeah. So what you see there is massive amounts, just pour everything there. It ends up in some kind of bucket. And then they will start building all kinds of features on it, and actually rebuilding the same data set over and over and over again in 3 different layers.
And then we'll see if we'll need it.
Yeah. Well, and even if they need it, no one's going back into actually, okay, we actually didn't need this, so throw these events out, clean out, purge.
I can
for me,
from
it feels like the moment you're moving a lot of stuff and then not using part of it is feels like the most obvious thing to avoid.
Yeah.
Also in apps,
exactly that. Exactly the pruning. You don't want to know how many times people just they just want a bigger set because it's handier later on when they actually need it. But the best example is, I think I worked, and it was completely coincidental. I worked for 2 years as a solution architect at the Nature Data Bank Flora and Fauna, which is the biggest nature data bank of the Netherlands. They have all animals, plant information, insects, anything. And when I started there, we had 100, in the 200 million observations, and that needed at least 2 terabyte of memory to run that Postgres database. This is public information because we're proud of how we solved it. Eventually, just by redesigning the architecture, looking how you can work with partitioning, mainly with partitioning, and how you also look at the quality of data and the things you probably not gonna need, and only use what you actually need. We went from that to just one virtual machine of 32 gigabytes of RAM, and making it completely work.
That's quite the optimization there.
Yeah, I have also other examples, but you need then. So when we were pretty bold. We're like, okay, we don't want to continue this because we think this should be way more efficient, and we have from a cost perspective a good reason. Not even talk about footprint perspective, but yeah. So yes. Is there a simple rule of thumb? I think it's often too complex, but
it's probably going to be an "it depends" answer, right?
Yeah, well,
yeah,
but it always is.
I think it's good to have the to know which intuition to follow, and maybe which things you think might be really good are in practice really bad. Because I can imagine there are ways of working that feel like, oh, but this is like super efficient engineering, and yours like, no, you're actually boiling the ocean right now.
Yeah,
like I don't know.
No, so if people are interested in this topic, right, and they want to start executing, or they want to at least inform themselves of how to take the next step, where should they go instead of, except for, of course, your meetup, which we will join in the description, or we'll add in the description of the episode. But is there like
information is
location
very
they can
scattered.
go?
That is one of the things that I still bring up every time with the Green Software Foundation. They try to be a standard and organization. So they also create the software carbon intensity formula that we didn't talk about. But for information, I always refer people to the climateaction.tag. It is a Slack community that is kind of the oldest. That what I say, some people are for more than 10 years in this field. So they're like, this is not new. But it is a community of 10,000 people, and you can ask often questions. So, hey, this is what I do. You can explain, I'm a developer, I want to start here. And people are there every day like, hey, this is the best resources you can go. Because like I said, it's so scattered. It is the best place, I think, to start. In general, if you want to know more just about green software and green coding and that kind of stuff, the Green Software Foundation, their free and open source training is also a good start to just get an overall idea on how this all works. But that is one of the key things. There's a lot of information at universities. That's also the things that I discussed when we didn't talk about. That was at CERN last week, or this week, I have to say. The information is pretty scarce. Yeah, all over the place. That's a bit sad.
But let's make sure that the ones that you talked about, at least we'll add them to the episode. There's actually 2 things I would like to add. The one is, since we were discussing, it was hard for me to think of the actual title. The funny thing is, go to an AI agent. I don't care which one you use, but go to it and ask it, create a Netflix-style series title and tagline for me based on my LinkedIn profile. Here's my LinkedIn profile. It's a lot of fun, I can tell you. I'm not going to mention them here because I think they're actually, like, for instance, Netflix always does. They brag a little bit, and I don't like to discuss whatever is on that list, but it's a lot of fun to do that because it's really, it's nice. Second thing is there anything that you would like to add to what we've already discussed that you would like to get back to?
Well, one of the things is we very shortly mentioned AI. So there are a lot of numbers out there about AI and networking that are horribly wrong, sadly enough. Not that AI doesn't have impact. Most impact is because of investments, not on how we people use it, like the chatbots or the CLI these days, which I use a lot. You have to know that kind of most the TPU, GPUs, or how you want to call the units, are capped at 300 to 400 watts. Most CPU is like on a heavy server, maybe 100 to 150 watts. So it's like 3 times the amount of energy you potentially use with AI. So time, and especially because AI, Gen AI, utilizes the GPU at 70-80%. It's very predictable in how energy is used. CPUs are way more difficult to calculate and estimate how much energy they use. So yeah, if you just use it very efficiently in a shorter time frame, it is not the worst thing to do, I think. The other thing is, no, I lost what my train of thought was there.
but at least it's good to know that you don't have to feel dirty if you use that.
Yeah. No, but like it is, but also like within, if you see the past year, how we use AI, if you're thinking about efficiency and whatever, like to me, it's it also feels weird. You're coding, you do a really complex thing, and it's almost a zero hit. Like, wow, this is like I'm almost sure that if I was working for 8 hours on that, my breathing would be more CO2 than the computer right now. So
yeah, fair enough.
But probably not. But like,
if you really want to be in control, just buy a laptop with a 5090 in it or a MacBook Pro. But
you know exactly what you're doing then, right?
Yeah,
like
because you use open code. A Gemma 4
like sometimes
is perfect.
You end up as like, oh, this like it's reevaluating this session context like time and time again, and I'm only centering a diff for the last 15 minutes. Like maybe that's the time to actually think about being
not clear, compact. Yeah,
or actually read a book first. So yeah, but it just you get sucked into it, and I think the behavior, and then it goes all the way back is like, what am I actually doing? Why am I doing this? And is it worth it? And I think that is the exercise of every skill in this, right?
Yeah. Maybe also a cool thing is in the next 2 months, we're starting next week. We're gonna do literally an assignment with GitHub. The assignment comes from California, from Paul Young, the sustainability officer there. And we're setting up, this will be publicly available. We're going to set up how you can analyze any open source project with the theoretical model that we created. So you can analyze where the energy and efficiencies are in. And the first we're going to try is PyTorch, not the smallest library. I already found multiple like inefficiencies, so I think we're good to go. But there are also ways to use AI in this matter.
So cool.
It's been very, at least for me, it's been a very insightful discussion because
we only started the surface, right?
Yeah, and I've already started to think about certain things where I think, hey, maybe I should change that up a little bit and make sure that it runs a little bit more efficiently. So thanks so much for being our guest today, Wilco. It was a lot of fun talking to you.
Yeah, thank you. Fun. Yeah, it was fun.
And thank you for listening to Beta Talks, the podcast. Beta Talks is made possible by Betabit Managed Software Development.
And we'll see you next time.
See you next time. Bye-bye.
Bye-bye.
Bye.